Welcome to this course on real time operating system. So, in this short discussion, we will just see what exactly is a real time operating system, where is it getting used, how is it different from a traditional operating system. So, in the process, as it may be clear that to be able to appreciate this course, we must have background on operating system, because those things will be assuming. So, let us see what is involved in this course. Before that, let me just briefly introduce myself, the instructor for this course. My name is Prof Mall. Did all my professional degrees, bachelor, master and PhD from the Indian Institute of Science, Bangalore, and then worked with Motorola India for a couple of years, and then shifted to IIT Kharagpur in 1994. So, that is about 23-24 years back, 23 years back, and currently a professor in the Computer Science and Engineering department. So, let us see what all we plan in this short course. So, here we will initially have a brief introduction to real time systems, real time operating systems, classification of real time systems, and then we will say that one of the major techniques that the real time operating systems deploy to meet the task deadlines is the task scheduling algorithm. So, we will discuss different types of scheduling algorithms that are being used, specifically the cyclic executives and the RMA and EDF. But then the scheduling algorithms by themselves can be used only for very simple tasks. In real applications, tasks do share resources, and when tasks share resources, the simple scheduling algorithms, they run into difficulties, and we will see that how these difficulties are overcome by using resource sharing algorithms. And then subsequently, we will look at multiprocessors, because nowadays multiprocessors have become prevalent. Almost every computer that we use, whether it is on a mobile phone or on a desktop or on a laptop, are now multiprocessors. So, multiprocessors are also being extensively used in real time applications, and therefore, we will see that the basic scheduling algorithms, how they need to be extended to be able to handle multiprocessor computers. And then one very important thing here is the standard. POSIX real time standard is the one which most of the operating systems they follow, because unless these follow the POSIX standard, these are not well accepted. These will not be interoperable with other systems, and therefore, normally we require POSIX compliance. So, we will see what is involved in POSIX real time, and then finally, we will look at features of some commercial and free real time operating systems that are available. But then let us have a very brief idea about the real time systems, where they are used, what are their characteristics, and so on. So, one important thing that we can say is that in all real time systems, the tasks have time constraints. At least some of the tasks have time constraints, and these real time operating systems, a majority of the platform are the embedded platforms. If you can see in the diagram that the embedded systems are a place where the real time operating systems, the number of real time operating systems deployed is possibly the largest. There are of course standalone systems which are not embedded, where real time operating systems are used, but those are see here smaller. But then not all embedded systems are real time systems, as this diagram shows. So, we will see that when we have a real time application, it is the real time operating system which helps the application to meet its deadline. And as I already said, that task scheduling is a very important component of the real time operating systems, and it is the primary mechanism by which the tasks meet their deadlines. So, a substantial part of this discussion will be on the scheduling algorithms, various types of scheduling algorithms and their extensions to multiprocessors, and we will look at some of the features of the real time operating systems and what are the requirements of the POSIX real time and what are the different operating systems that are available and how well do they meet these requirements. And then we will be following a book that I had written, Real Time Systems Theory and Practice, Pearson Press. So, this will be our primary text, and then we will have supplemented by several referred white papers, tutorials, and also books by Liu and Krishna and Sin. But then we are saying that the embedded systems, the number is becoming extremely large, they are increasing at a very rapid pace, the number of embedded systems. So, these are the major clients of the real time operating systems. Let us see what has led to a rapid explosion in the number of embedded application over the last 10 or 20 years. So, one of the major factor here is computers becoming cheap, processors, memory, etc., and that allows computers to be used even on cheap systems. For example, a computer mouse or maybe a camera, they all have computers inside them because the computers have become extremely affordable. And the other thing is that the computers have the power consumption has reduced. So, embedded systems, these are typically powered by their own battery, and therefore, long battery life is important, and these systems nowadays consume very little power. And then the flexibility due to internet, many of these embedded applications are interconnected, and that has made them much more popular. And also their sizes have reduced, processing power has increased, and the reliability has increased to an extent that they can be used in very safety critical applications. Earlier only mechanical systems were used. For example, in a typical car, 50 to 60 processors are being used and hosting real time operating systems. But then, just to get a glimpse of what we discuss in the lectures, the first thing is that anybody will ask this question, that how is a real time operating system different from the other operating systems. The first fundamental difference is that traditional operating systems, they are based on the concept of fairness and maximization, minimization of the average response time. So, how fast it can respond to a command, and also the tasks have to be scheduled fairness. So, minimization of the response time, average response time, and task fairness during scheduling. These are two major concerns of traditional operating systems, whereas in a real time operating system the concern is meeting deadlines of the tasks, and obviously when you have to meet deadline of some tasks, the operating system cannot be fair. So, real time operating systems are not fair, and also the average response time here is not important. As long as all tasks meet their deadline, that is a good metric to check whether the operating system is good, rather than whether the tasks complete very fast, because as long as they complete within their deadline, that is good enough, and even whether they complete in a fraction of the deadline or towards the end of deadline, it hardly matters. Now, let us see what are the basic requirements for a real time operating system. The first thing is real time priority levels. Actually, the traditional operating systems like Unix, Windows, etc., the priority level keeps on shifting in every time slice. So, in the course we will see why the priority level shift in a traditional operating system, what is the algorithm using which these shift, and then we will say that these are not suitable. A shifting priority level with time is not suitable for real time applications. So, the first requirement is a fixed priority level. The second thing is about the task scheduling policy, and said that we will spend good amount of time in discussing the important task scheduling algorithms. And then the third requirement for a real time operating system is support for resource sharing protocols. So, we will look at some of the important resource sharing protocols, and also we will see that the requirement for a real time operating system is low task preemption time of the order of a milli or a microsecond, interrupt latency requirements, memory locking support. We will see what is memory locking and why memory locking is required, timers, real time file system support, device interfacing, etc., which we will briefly look at. And just to summarize, this is a course which will introduce to the important aspects of a real time operating system over 10 lectures, and we will have several numerical examples to get a feel of how, given a task set, whether we can say that it will be schedulable on a given machine, or whether we need to optimize the tasks so that they can meet their deadlines. So, that is briefly about the course. Thank you very much.